All right, introduction to greenhouse management. Here we go. There is a quiz on this. I'm not sure if we're going to go do the quiz. The quiz is much like the last quiz we did, just kind of for your own self, just to get your definitions down and that kind of stuff. If we have time, we'll go through it. We may or may not. So today we're going to talk about 5 different types of greenhouses: permanent greenhouses, hoop houses, also known as high tunnels, cold frames, hotbeds, and low tunnels. Those are the most common things you'll see in this climate. So as we are just saying, a greenhouse usually refers to something that's permanent. So you're talking about a permanent or semi-permanent structure, and as such, it is subject to municipal bylaws. So before you build a greenhouse, you need to go and make sure you're properly zoned for it, make sure you're in the right area, this and that, so that somebody doesn't come along later and tell you to take down what you thought was going to be a permanent greenhouse. Now at Hayes Farm here, technically what we have up is a hoop house, but for all intents and purposes, we use it as a greenhouse. Now, I may be getting ahead of myself a little bit, but the hoop house at Hayes Farm, in theory, we could take down those hoops in a day and it wouldn't even be there. You'd have the planters sitting there yet, but the hoops could be taken down in a day. It is not permanently plumbed in. We just have an electrical line that runs overland to it, which I'll admit is a little bit dodgy, but that's what we have going on right now. We have a plan to trench it, but we haven't got there yet. And so technically what we have at the Hayes Farm could be classified as a hoop house, but when we talk about greenhouses, we're talking about permanent structures. Often they're grouped on a lot with other commercial or residential buildings. They are often either double walled or insulated, just like the Hayes Farm hoop house has that blower to blow apart the 2 layers of plastic to make it double walled. There is often a heating element, often like permanent heating elements, like say natural gas plumbed in. There's often water plumbing element. There's often an electrical element to it. And there is many different types of permanent greenhouses, and we'll go through the more common examples. And most often in a permanent greenhouse, such as say like Scott's Nursery, for example, is a great example if you guys ever wandered through there. Most often in permanent greenhouses, you're not growing directly in the soil. Most often in permanent greenhouses, there's tables where you're growing things in different trays or pots or containers of some sort. That's what you'll most often see in permanent greenhouses. So hoop houses, though, also known as high tunnels, they are often constructed in a field. Not a permanent structure, and in theory can be moved and dismantled in one day, and as a result, there are no bylaws that apply to them because they can just be taken down at any time. Sometimes it'd be a heartbreak to take it down at the wrong time of the year if you were forced to, but in theory, they could be moved and dismantled all in one day. Most hoop houses are single walled, but they can also be double walled, such as the one at the Hayes Farm here. Most often they have no supplemental heating, except for perhaps a little quick rigged up system for abnormally cold nights. Most often no permanent plumbing, maybe just a hose run over land. Most often no permanent electrical hookup. Often they're more passive than a permanent greenhouse. And often in a hoop house, you're growing in the soil, directly in the soil inside of the hoop house. Hoop houses can range, just like greenhouses can range in a variety of prices. Hoop house can range in a variety of prices from low-end constructions for like under $1,000, and we'll go through some examples there, to very high-end examples for like over $15,000. Hayes Farm hoop house right now, with all the different bells and whistles that we've installed so far, we're probably at about $10,000 worth of cost for the hoop house, and the plastic, and the roll-up sides, and the planters, and the fill, and you name it. We're probably up to about $10,000 in cost. Hayes Farm hoop house, just so you know, came from Scott's Nursery. We paid $960 for a 96-foot long hoop house, and that's basically the price you're looking at. They have more hoops available at the nursery, and if you guys are interested in building a hoop house much of the same dimensions as Hayes Farm here, very possible to do. You guys can do it, and I can set you up with the right fella that I can sell those hoops to you. Okay, so that's greenhouses and hoop houses. Now we're going into cold frames. Cold frames are usually often simpler, smaller versions of the hoop house. They're often square. They're often around knee height with a removable lid. They're often single-walled and not doubled. They often have no supplemental heating or plumbing. And they're often more passive than, say, your proper greenhouse. And there's all sorts of different types and designs available for cold frames, and we'll go through those too. Hotbeds are often cold frames or inside of a hoop house or inside of a greenhouse. Hotbeds is you're just trying to provide some heat to your substrate, to your soil there, with some sort of heating element to it. Sometimes they're electrical, sometimes they can be hot water pipes, and sometimes you can be using fresh manure underneath. Like you excavate soil, you put down some fresh cow or horse manure, put the soil back on top, and that manure, as it breaks down, will heat up that soil on top of it well enough to grow plants in the middle of winter. Pretty neat system. I've seen my Amish friends there use that several times to advantage. Most often hotbeds are used for starting seedlings early in the summer. And it's very easy to create a hotbed inside of a greenhouse or a hoop house. Now, as opposed to a high tunnel, you can also opt for a low tunnel. And basically, these are looking like little greenhouses out in the field. Sometimes low tunnels are called mini tunnels. They're often around knee height. We have some of this material on the farm. We've used low tunnels to grow basil on Hayes Farm to great success in previous years. They are often just set up right in the field over top of an existing crop. You're often using those spring steel hoops, same things that you see inside the hoop house that are over top of the heated plants. Those are very handy, and I can show you a source for those if anybody's interested in ever purchasing some spring steel hoops. And if you notice in this picture here, it's not solid plastic like the high tunnel or greenhouse plastic. You're dealing with perforated plastic here. Any thoughts about why the plastic is perforated?
Maybe like
is it just for airflow?
Right. Otherwise, if this was solid, this would reach temperatures of probably like 40, 50, maybe even 60 degrees Celsius, and you could cook your plants. You can buy different low tunnel plastic with different percentage of holes in it based on what temperature your optimal temperature is that you're growing plants underneath. As I said with the greenhouse here at Hayes Farm, if you're growing mixed crops, you're typically aiming for about 27 degrees Celsius, 80 degrees Fahrenheit. That's your sweet spot. And when I purchased my low tunnel plastic, that was the temperature range that I purchased. So it's to hit that 27 degrees, 80 Fahrenheit. These low tunnels like this are fantastic for giving things like peppers or tomatoes or eggplant a start out in the field, but you can't keep them in there forever. Those plants I mentioned anyway in particular, because they'll eventually outgrow your low tunnel. But in the early part of the season, it will really speed up their growth. It can get you ahead of your competition. And if you are working on a for-profit farm, being the first to market with any crop is always in your best advantage. Much like using row cover, which we haven't used very much yet, but we will this week, the edges of the low tunnel are often just buried with soil. Okay, so during the introduction kind of part there, I was talking about different variables. I gave you that beef cattle example about that farmer who's not growing beef cattle at all. All he's growing is the grass, and as long as he grows good grass, the cattle take care of themselves. So in the greenhouse, as long as you're having good management over your temperature, over your light, and over your airflow, then the plants are going to grow themselves. That's my point here. So the three most important greenhouse management variables are temperature, light, and airflow. Now, when you talk about light, that is both the strength of the light getting in and the length of the light, like the hours of light versus darkness in the greenhouse. So here, when we talk about, when I'm boiling it down to just those three variables, I'm not talking about the individual needs for the plant. So if you're growing, say a rosemary plant versus a cabbage plant in the greenhouse, they will have different water needs and different water requirements. They will probably have a little bit different fertility needs and fertility requirements. They might like to be grown in different soil structures. And those are very individual, kind of the what we'll call the micro variables in the greenhouse to control, as opposed to the macro variables. So when it gets to just like overall greenhouse management, the 3 macro variables I want you to remember are the temperature control, the light control, and the airflow control. Okay, next here, and we'll revisit those as we go on, that those will become kind of constant themes here. So next I want to talk about types of, we mentioned permanent greenhouses, we mentioned hoop houses, we mentioned low tunnels, cold frames, hotbeds, and now we're going to go through different types of each of those. So we'll start with permanent greenhouses and visit common types of permanent greenhouses. As you can see here, we got 6 different ones to go through. The first one is post and beam. Usually when somebody is building their own greenhouse themselves out of lumber, this is the type of greenhouse that is most common to build. It's called post and beam for obvious reasons. That whole thing's built out of post and beams. Often this type of greenhouse will have those acrylic sides I was talking about, or glass is another one, but like as I was saying, you typically see glass more kind of hobby backyard kind of style. Not that there's nothing wrong with that. Then you see the acrylic is usually used more in business kind of style, because the glass is going to be more work. Even if it might be cheaper to purchase up front, over time, it's going to be more work and more labor to maintain those acrylic sheets. So that's your post and beam. Another popular type of permanent greenhouse is your A-frame. And instead of being post and beam, you're still dealing with wood and you're just going A-frame style. I just built an A-frame chicken coop this past winter for my chickens, and I'm pretty happy with it. Much the same kind of design here. Then you have your attached or lean-to style. This is what I used to have at Grassroot Organics. If you have an attached greenhouse, that basically just means it's attached to another building. What side of the building do you want your greenhouse to be on?
South.
South and or west is your best sides for your greenhouse. That's going to get you the best sun. And here again, you're probably looking at probably acrylic sides is what you, especially this one here, definitely acrylic sides. This one here, maybe glass, maybe acrylic. I know a grower who attached one like this onto, much like this picture, onto their old farmhouse, and they use it to heat their farmhouse sometimes. They do an air exchange. The only problem you have to worry about there is the moisture that will come in from the greenhouse into your house, and it can cause mold issues, and he actually had to do something to mitigate that a little bit. Pit style greenhouses. Apparently there is one of these in Nova Scotia on some sort of demonstration type farm. It was Kate Copage that was telling me about this. I have never seen one of these in real life. Apparently on this farm, this is an old heritage kind of farm in Nova Scotia. It's just more a demonstration than anything else. But apparently it was original to that farmstead back in like the 1800s, and they had it working for them, which is amazing. Like I said, I've never seen one of these in real life. I've read about the theory, and the theory is really neat. The theory goes kind of like geothermal heating, that once you dig down, say 6 to 10 feet, the temperature is going to remain relatively the same year round at that level. And so it will never go below freezing, and especially if you can get the sun and greenhouse effect happening, you can get quite a bit of heat inside there. Interesting concept, and possibly you might be able to grow things year round. In this climate, I would worry about snow load, that's for sure. I don't know how you get the snow off of there. And that would cause everything to go black real quick underneath there. But nonetheless, pit style greenhouse is certainly an interesting style.
We built one at the Ville.
And?
It works.
And tell me more.
We put in Home Depot gravel, 6 feet down, raised beds above it, and then using water pumping through it. It's entirely regulating because the fish below the beds actually clean up the water.
You're talking about the aquaponics one. I didn't know there was a pit. I didn't know there was a pit involved in that. Is that where the fish is then? Does the fish go down into the earth?
The fish are in a tank on the earth, but the earth stays at the same temperature, so it keeps the fish alive. And then it's a pretty dope setup, actually.
See, but now that one, the vegetables are being grown above ground, not below ground, correct?
Yes, but the heat from the earth and the soil battery itself maintains it's all good for a whole winter.
Yes. See, to me, that sounds more like you're tapping into geothermal rather than a pit-style greenhouse. Because to me, a pit-style greenhouse is you're growing stuff like basically underground. Whereas there, don't get me wrong, still very clever. But that seems more like you're tapping into more geothermal technology in order to grow things above ground year-round, which is super interesting.
Yeah, it's pretty cool to see how some of these greenhouse ideas can integrate each other's benefits to get like more optimization based on where you're building up at.
Yeah, way cool. Especially, exactly what you're saying. To combine different things, to stack the elements on top of each other, basically. Geodomes is the last one here we're going to talk about in the permanent greenhouse category. Has anybody seen a geodome out there in the world? And typically, where do you see geodomes out there in the world? Nothing? Nobody's got nothing on geodomes? Typically, you see geodomes more in the northern reaches. Canada and Russia, all like Nordic places. Sweden uses them as well. I think it has to do with snow load and high winds up north. You also do see them occasionally in other places too, further, not quite so north. But geodomes are typically, they seem to be the greenhouse of choice when you get up into like Arctic type areas, tundra type areas. And I'm guessing, I don't know 100%, but I'm guessing it has to do with snow load and wind on them. And I think they're very tough to take both of those kind of things. Typically, to build like your standard hoop house on a farm, if you're looking at like a for-profit type operation, a typical hoop house, much like we have here at Hayes Farm, is going to be much cheaper to build than say a geodome, unless you inherited one or something along those lines. But I imagine there's a reason that you see them up north, and such as I said, it's probably snow load and wind. Okay, so when we talk about greenhouses, when we talk about permanent greenhouses, one of the things that we mentioned is permanent greenhouses are often double walled, and that can be accomplished with that one sheet of acrylic siding or acrylic greenhouse plastic. One sheet will be double walled in that sheet itself. Or you take your flexible plastic, such as we have up at the Hayes Farm, and you install a blower. And that's what this picture is. This fella here is installing a blower. And that blower doesn't take up very much electricity at all. I was told it's about the equivalent of running a hairdryer constantly. And it just inflates the 2 layers of plastic. And it really does make a difference. Like as much as like 4 to 5 degrees Celsius difference at night, just having those 2 layers of plastic inflated. It's a great thing. Typically, your modern hoop house with your metal frames will either be a Quonset style with its gable arches, or a Gothic arch, which has a nice point to it. When you get to areas with more snow load, the Gothic arch is preferable because it sheds it a lot easier than the Quonset, which is basically your round circular. The Hayes Farm hoop house is kind of someplace in between the two. It's not quite a Gothic, not quite a gable. It does shed the snow okay. Yeah, it's. I would rather it be a little bit more pointy is nice in order to shed snow. There was occasions we were out here in the winter with big long brooms trying to take snow off the hoop house. Oh, and another thing too. Okay, so this is a surprising one, and it took me years to agree with it. But all the experts tell you that the taller your greenhouse is, the more even your temperature is going to be in your greenhouse. The easier it will be to heat and cool your greenhouse, the taller it is. And I don't quite know the science behind it, but I can tell you from experience that certainly does seem to be the case. It seems to be able to heat and cool a greenhouse easier the taller it is. So as I mentioned before, three most important greenhouse management variables is your temperature, your light, and your airflow. And we'll keep coming back to that. So I just kind of want to hammer that into you. So when you get to the Hayes Farm hoop house in the morning or in the evening for close or open, those are the things you're looking at. You're looking at temperature control, which is often going to be controlled by ventilating the hoop house. You're looking at light. There's really not much you can do about light. In our hoop house, we don't have any supplemental light. And then you're also thinking about airflow. Right now, we just have one fan working in our hoop house. As it gets warmer, we'll get up a second fan running in the hoop house too. So here are some popular accessories to go into permanent greenhouses. This is an auto vent, and this is something I would like to install into the future in a Hayes Farm greenhouse. The very front of the greenhouse, we have a door off to the side, and then we have a solid sheet of plastic. What I'd like to do is install something that looks like this, where you triangular off a top, and then you install an auto vent. These auto vents run, these might be a couple of years out of date, maybe up to about $50 nowadays per auto vent. And they run on hydraulics, and you can set them to different temperatures, or you can purchase them at different temperatures, that is. And if you say purchase one that is set for 30 degrees Celsius, as soon as the temperature inside the hoop house gets to 30 degrees Celsius, it automatically hydraulically opens up a door. It excites the gas molecules inside the piston or pump here, and then it automatically just opens up the vent. And depends on the size and the scale and scope of your hoop house, but you can install one like on every single roof panel all along your hoop house if you really want to. And as soon as the temperature goes down below whatever it's set to, it'll automatically close itself. And so as you can see, for a hoop house like Hayes Farm, where we are scheduling morning and evening close and check-ins and this kind of stuff, having something that automatically vents could be a very good thing. The next step up from the auto vent is your exhaust fan. And this here you can set up on a thermostat. Of course, it's going to be more expensive to have a whole exhaust fan system. But if you have a very large greenhouse and a large greenhouse operation, an exhaust fan is what you're looking at as a step up from the auto vent. This is something that you'll see in all the professional greenhouses, such as Scott's Nurseries, are the movable benches, and these are ideal. Essentially, in a greenhouse, it allows you to have a greenhouse that looks as packed as this. These are all being grown on benches and tables, and you can move the benches and tables to create. Right now, we have a pathway that leads right here, but that pathway can be literally anywhere in that hoop house by sliding along these benches and tables along these sliders. And you can create a new pathway anytime you want. And that allows you to get down here for management as opposed to just trying to manage these plants from all the way over here. And as we talk about our three greenhouse variables, this allows you for more airflow control. Anytime you need it to open up any kind of plants, you just create a walkway there if you need to get a little bit more airflow there. And it allows you some high density in your greenhouse. This is something I used to have in my old greenhouse at Grassroot Organics. I used to have a 100-foot long greenhouse, much like here at Hayes Farm. This seems to be the most popular type of heating at the moment for professional greenhouses, are these Modine heaters. You can buy them up to 97% efficient, so there's hardly any emissions. I've even heard about 100% efficient ones, but I've never seen them in real life. Often you're looking at propane or natural gas in order to run these. Once upon a time, if you go visit any greenhouses that were built, say, in the 1970s or 60s, 70s, or 80s, and they're out there, they were all built with electric heat in mind, and all of those systems are all abandoned now. Most heating done in professional greenhouses is looking like something like this. Scott's Nursery has a hell of a system for heating. They have a big old boiler that they have in a main greenhouse, and they pipe heat all over the place. It's crazy. For a small Modine heater unit, you're basically looking at $1,500 plus installation, plus fuel. And then it has a big old blower fan in here. And you can run the blower fan with or without heat, and that will really help control your temperature inside the greenhouse and your airflow inside the greenhouse. Very good tool to have. That is like the conventional standard nowadays is the Modine heaters. Beyond that, especially on a smaller scale, and especially if you don't want to be using natural gas or propane, you get into some wood heating. I know many Amish growers that were heating their greenhouse with a wood stove. Here's a very crude setup, but I've seen a lot more sophisticated setups. I even had one Amish friend that had their wood stove installed so that the stove itself was just on the inside of the greenhouse plastic, but the door opened to the outside, so you never had to carry wood inside the greenhouse. You can just feed it from the outside of the greenhouse. And then the stovepipe he had going up from on a very slight angle from the bottom of one side to the very top of the other side. So it ran the entire length of his greenhouse. It ran the entire length of his greenhouse and provided heat for the entire length of his greenhouse. It was a very nice setup. The only drawback there is the less slope you have in your chimney pipe, the more difficult it is to start a fire, because there's often a lot of backdraft that happens. But assuming you can get that fire started, having one heater with a big long stovepipe can heat your entire greenhouse using wood. That ideally, if you're on a 100-acre farm, maybe you're harvesting from your own woodlot in a sustainable manner. The only problem with that is you are then looking at getting up in the middle of the night to feed your wood stove. And if it's just you running a farm operation, that gets old really quick. At my Amish friend's house, they had families of literally up to like 12 kids in some families. And it was an honor. They used to fight to see who was going to feed the wood stove in the middle of the night, because they only got to do it like once a week. They set an alarm for the middle of the night, and they got to go in the middle of the night and look at the stars and feed the wood stove, and they loved it. But if it's just you doing it, and you have to get up every morning at 3 o'clock in the morning to feed this wood stove, that shit gets old fast. So you have the pellet stove. The pellet stove is a self-feeding stove. You have a big hopper that you can fill up with pellets. And then as the pellets get burned in the stove, the more pellets just keep falling down and feeding the stove. And that way you don't have to get up in the middle of the night to feed it. You have a self-burning pellet stove. Problem with that is you're now unable to go harvest your own wood from the forest to feed the fire, and now you're relying on buying pellets. Well, you can make them too, but it's a bit of a pain. I've heard about some growers experimenting in the self-feeding pellet stove with corn that they grew themselves with some degrees of success. Not corn, corn cobs, that was it, corn cobs. So another style of heating a greenhouse is with water heat. So here you're looking at a tubing that gets hot water run through it. The thing about this though is you really need to pre-plan your greenhouse. You can install this with either water running through that tubing, or like me and Jared were kind of talking about there a little bit anyway, some geothermal. If you have a duct going down deep into the earth, pulling up the temperature and the air from the earth, you can run that through those pipes as well. It's not that expensive to install, but you have to be able to pre-plan the whole thing. That's the whole thing. Most people, when they build a greenhouse, they first just kind of get it up and running, and then they think of ways to heat it and this and that. If you're going in this direction, you got to plan this out from the very start. And here it looks like they've excavated a bit too to get down, which is probably a good idea. Another accessory is using passive heat sinks. So how this works is you're looking at big old drums of usually water on the back wall of the greenhouse. And this is something I've done at my greenhouse in Ontario, and it does work out. The math behind it tells you that for every 1 degree Fahrenheit, that 1 pound of water cools, it lets off 1 BTU. And a BTU is a unit of heat. It's your British thermal unit is what it stands for. And it's a standard unit of heat. Much like watts are a unit for electricity, BTUs are your units for heat. So every 1 degree Fahrenheit, that 1 pound of water cools, it lets off 1 BTU. Now, when it gets down to freezing point, each 1 pound of water lets off a surge of 144 BTUs, which, you know, it's not exactly going to feel like heat to you and me, but it's enough to mitigate the temperature in that greenhouse by a few more degrees. And sometimes that's all the difference you need. Other things that can be used as heat sinks would be sand or concrete blocks, but I find water works real well. This here is a super cool accessory. We were talking about the need to have a double-walled greenhouse and the advantages of the double-walled greenhouse and that fact that it does mitigate your temperature by as much as like 4 to 6 degrees Celsius. If you have a greenhouse that's out in the field and you're not able to run electricity out to it, or if you don't want to run electricity out to your greenhouse, you can purchase these plastic spacer blocks. Johnny Selected Seeds carries them, and they go 1 in each corner of your greenhouse, and they're just made to clip on here or there, and then you pull over that second sheet of plastic and you're able to get a second sheet of plastic over it tight, and it does make a world of difference. It does change, it heats up your greenhouse quite a bit. And then another accessory on the opposite end is shade cloth. Sometimes your greenhouse gets too hot and you want to be able to grow a cooler crop in there, and then there's a shade cloth that you can pick up and put over top of your greenhouse. We actually have some of this in one of the old horse stalls at Hayes Farm if you ever want to take a look at some shade cloth. And as far as bringing it back to those 3 greenhouse variables, both of these materials will help you with temperature control and with light control without needing the electricity. Okay, so light control, here's more on that. If you're trying to if you're trying to lessen light, shade cloth is good for that. If you're trying to add additional light, nowadays it's all about the LEDs. 10 years ago, it used to all be about high pressure sodium lights, but they're very expensive to run in electricity, and electricity cost keeps getting higher and higher. Nowadays, in every professional greenhouse, everybody has switched over to LEDs. There is a fantastic article here about different spectrums of LED lights. And I know this was being experimented by the University of Guelph. This one here is from Michigan, but the University of Guelph was also running experiments on this. They were working with Greenbelt Microgreens was the name of the operation in Ontario. And in the Greenbelt Microgreens, well, they grew microgreens, and it was like basically a 4-acre greenhouse. And they had whole bays that were set up with different color combinations of LED lights for growing similar plants, and they were trying to track what lights did best for what plants. Super interesting stuff, and it's science that continues to evolve right now. If you're looking to improve airflow in a hoop house, we were talking about fans, and we were talking about exhaust fans. We have the side roll-up crank at Hayes Farm hoop house, which is a great thing to have too. If you're looking at big greenhouse operations, they all have a ventilation plan. And as a grower with a greenhouse, it's nice to be able to understand how the air flows through your greenhouse and try to come up with a plan in order to flow it through your greenhouse. Let's see if I have a slide for that. Nah, not so much. At the Hayes Farm greenhouse, eventually we'll have two fans set up. And when I do, I'll have them running in opposite directions. So you end up with a flow that goes through your greenhouse up on one side and then kind of back down on the other, just to be able to move air through your greenhouse. And that will certainly help against plant diseases and plant pests. As I was saying before, we always try to make the greenhouse a little bit more on the drier side than on the wet side. If your greenhouse remains too wet, you'll often end up with plant diseases, plant pests too, like insects that is. On the dry side, with a lot of ventilation, you'll avoid that kind of stuff. So we try to get a lot of ventilation as we can in the greenhouse. Is anybody familiar with a plant disease called damp off? That is a plant disease caused by too much water in the seedling stage. And how many folks have seedlings started right now? Want to raise a hand if you have seedlings started at home anywhere? Do you ever have a problem with your seedlings right at the base of the soil where your seedling comes up? It seems as if the stem gets weaker and then the whole top of the plant falls over. Has anyone ever seen that? That is a condition called damp off, and a lot of beginner growers will experience this because as a beginner grower, you're growing these plants and you want to give them love. And sometimes the best thing you can do to plants is not do anything and let them dry out. But every morning, you know, especially if you're new to gardening, you'll water your plants because that's what you do in the morning. You water your plants. Sometimes you get home at night and you're like, oh, look at my plants coming along. I'm gonna go water again. And you keep watering your plants, and then you're gonna kill them with too much love. You end up with a plant disease called damp off, and the plants just all kind of end up falling over. I've had a couple of instances of that myself. Every year I run into instances of this because I always try to start too many plants in one area and try to do the best I can with what little I got, and set up fans inside my house and this and that, and I end up with a little bit of damp off. And if I ever see some, I'll point it out to you in the greenhouse. But right now in the greenhouse, we're pretty good. The planters really help with the damp off. Okay, so now we are talking about permanent greenhouses. We were talking about permanent greenhouse accessories. Now we're moving into high tunnels. So high tunnels, as opposed to greenhouses, often high tunnels are very similar in structure. However, the building materials and styles can vary. You can have a very high-end hoop house that pretty much, for all intents and purposes, kind of is a greenhouse. And that's pretty much what we got here at Hayes Farm. Here is a high-end hoop house with cross beams and a nice high peak to it, and it can be double walled. And in theory, it could be taken down in a day. And in theory, it doesn't have permanent plumbing, doesn't have permanent electricity, but it's a really nice high tunnel, a really nice hoop house. You can have medium-style hoop houses, which are a little bit smaller, than your high-end hoop house with a nice tight peak to it. This here is a little bit lower in elevation. It maybe is only single-walled. It still has nice roll-up sides to it, and maybe you're looking at spending around $6,000 for this, for a 100-foot medium kind of hoop house kind of style. And then finally, on the other end, you can have some low-end hoop houses. These can be made out of just conduit or rebar, and then vapor barrier purchased just at Home Depot as opposed to greenhouse plastic. You could spend maybe about $1,500 for a 100-foot long hoop house that looks like this. Or you can even go super cheap, and this here just looks like it's built out of flexible conduit with a UV treated polyfilm sheet. And as opposed to attaching it to the sides with, say, lumber or wiggle wire, which is what we use at Hayes Farm, and we'll talk about wiggle wire in a second, you can just simply bury the sides with dirt and it'll hold it very nicely. And you could maybe perhaps build a small 20-foot long greenhouse for maybe $200, maybe even less. So those are examples of some high tunnels. At my house at Crocs Point Road, I have a hoop house that kind of looks like this one here with the ducks a bit. The sides are permanently attached with wiggle wire, but it's just a small little guy. I don't even have a door in it. I just kind of squeeze my way in the side, and I've been using that for 2 years just at my home plot, and it works really well for the size and scale that I operate at. It didn't cost me hardly anything to put up. There's a whole range of different stuff. Now, we were talking about here conduit. Does everybody know what conduit is? Can anybody help us out define conduit?
Is this the hollow piping used to carry wires and whatnot?
That's exactly it. So conduit is one material that it can be built out of. PVC pipe is another, and that's much like our black poly pipe that we have around the farm. Some conduit is flexible, and that's what you would need to build something like this. And some conduit is rigid and not meant to be bent. And that's basically all you're looking at. And here with the conduit, you're looking at pieces of rebar. Does everybody know what rebar is? Can anyone provide a definition of rebar?
Pointy, uncomfortable, hurts to get stabbed with.
Hurts to work with. Yeah, everything's uncomfortable about rebar. Rebar is just basically metal rods. They come in various thicknesses, from anywhere from like 1/4 inch to inch thick. They're very unfinished, that they're rough on the hands. They can be in 4-foot lengths, they can be in 12-foot lengths. And you're just talking about metal bars. And so with the rebar in this example, I would cut 4-foot lengths of rebar, and rebar is manageable with a hacksaw or a sawzall with a very fine blade on it. And you stick that rebar in 2 feet into the ground, 2 feet above the ground, and then you have all of these rebars pieces sticking above, and that's what you're going to put this conduit onto and fold it over, or the PVC piping and fold it over. And that's it. That's how you build a low-end hoop house. You got 4-foot lengths of rebar, half in, half out of the ground, and then either conduit or black PVC pipe that goes over top. In this case, he felt as if he needed to build something to give it a little bit more stability here in the middle, and he's got a little bit of an arch built. But it can be just as simple as that for a low-end hoop house. Do you guys want to talk more about low-end hoop houses? Because I tend to spend a little bit more time on the low-end hoop houses, because when you're getting into agriculture, this is your entry point. Your entry point is usually not a $15,000 greenhouse. Your entry point is usually one of these guys. Even if you don't have anything to mention now, if you know later when you're thinking about this lecture or whatnot, you have more questions about how to build one of these, I'd be all game to talk to you about this. I have built all sorts of different funky hoop houses and cold frames over the years. Okay, so I mentioned wiggle wire and channel lock. This is what's happening at the Hayes Farm hoop house. This is what holds our plastic in place. This stuff is genius. It can withstand such huge, strong winds and never budges. It's great to use with greenhouse plastic or great to use with tarping material. And basically, you're looking at installing the channel lock. That's this stuff here. It's called channel lock. You're looking at mounting that to your hoop house. Sometimes it's done at waist height. Sometimes it's done down here, and then often it's done around the perimeters here to keep it on both ends. And you're mounting this channel lock. Then you're going to drape the greenhouse plastic over top, and then you're going to install the wiggle wire. The wiggle wires come in length, usually around 6 feet, and you just start with one end and just clip in the wiggle wire into the plastic, and that plastic is not going nowhere. It's great material. You can order this in from the Halifax Seed Company down in St. John. It's great material to use, like I said, for tarps even too, for building like a quickie woodshed or something like that. We built lots of those on the old farm, or a quick lean-to off of the barn. Channel lock and wiggle wire. There you go. Here's the price for you, approximately $100 for 10 6.5-foot long pieces. Inexpensive, and it's a great building material. I wanted to talk about greenhouse plastic for a second. I'm not sure if I have a slide on that, but over here I was talking about using vapor barrier, and over here I was talking about using UV poly film sheet. And then over here on a proper greenhouse, you're looking at having actual proper greenhouse plastic. This here is your very low end. This here is vapor barrier. You can buy this at Home Depot, Home Hardware, you name it. Any of those kind of shops carry vapor barrier. It's intended to, say if you're building a house and you have insulation in your walls, by law you're supposed to put up a vapor barrier over top of your insulation in order to keep all of those fibers in place, and that's all it's intended for. It is not intended to be used as greenhouse plastic. If you use it as greenhouse plastic, and I have, you'll get one season out of it and it'll fall apart on you in that second season. So that's the downfall. It's cheap stuff, but you're buying plastic that you're just going to throw away in a year, so it's a bit of a heartbreak for me anyway. Whereas you can also go out and spend a little bit more money and buy a UV treated polyfilm sheet. And again, this is not intended for greenhouse plastic, but it is intended to take on some UV, and that's what breaks down this vapor barrier. The vapor barrier is not intended for UV. The UV makes it brittle and will break it down. Whereas this stuff here, you might be able to get 2 years out of a UV treated polyfilm sheet. And then if you have proper greenhouse plastic, when you're buying the greenhouse plastic, you can choose to purchase 2-year, 3-year, or 4-year plastic. I have purchased 4-year plastic for the Hayes Farm, In previous years, previous experience, when I have bought 4-year plastic, I get 8 out of it. The problem with pushing that though, and the reason it's 4-year plastic is it's because it is UV treated, or it is treated to withstand UVs for 4 years. After that, it is no longer under warranty or under guarantee. And also, if you're growing crops inside your greenhouse, especially lettuces, especially red lettuces, you don't get those vibrant reds inside of a greenhouse without that UV treatment on it. Right now, we have some red lettuces that are being grown in our hoop house, and they have a nice color on it. But as that plastic ages, those colors will be washed out. And I don't quite know the science behind it, but it's super interesting to me. Roll-up sides is a popular hoop house accessory. We have this happening at the Hayes farm. There are different options available. This one here is an option that you have to set after you roll it up. I have heard stories about people cranking these up on the sides and then letting go of the handle, and then the handle will just like, it'll roll back down like mad. And I've heard about people getting broken fingers, and I've even heard about a broken wrist. We opted for a little bit higher grade here at Hayes Farm, which is the middle one here, which is has a little clicker in it, and every time you roll it up, it just clicks up and it will never roll down on you, and unless you, of course, crank it down, so you have nothing to worry about with the Hayes Farm roll up. And then you can also buy a completely automated roll-ups where you just click the button and then the whole thing rolls up for you. The Hayes Farm was the first time I have installed my own roll-up. It's supposed to roll up the entire side all the way up. Mine doesn't. Mine goes down on a bit of an angle, and that's why that job on the to-do list is there for me to prepare that and kind of keep tweaking on that one. Irrigation systems, whether you're talking greenhouse or hoop house, great accessory to have inside the hoop house. Overhead micro sprinklers versus drip irrigation in the hoop house are far better than micro sprinklers or surface levels in the hoop house. If you have a surface level irrigation system or micro sprinklers, what will often happen is, especially as your plants grow tall, whatever plants are near these sprinklers will get all the water and they won't travel very far. So a drip irrigation system is nice to have inside of a hoop house. I think the micro sprinklers on the ceiling is the absolute best system that you can have because it will water everything in your hoop house nice and even. These are hose ponies, walking hose ponies. Have you guys ever seen any of these? Super cool. It works just on the water pressure of the hose. So let me see what kind of slides I got here. Oh, just the one. These are super cool. Walking, if you guys were to Google walking irrigation systems or something like that, you can see some YouTube clips. And basically what you're doing here is you're pulling out this wheeled sprinkler, and you're going to pull this out to wherever you want it to go on the farm, as long as you have enough length of hose to get there. So if you have a 100-foot length of hose, you can stretch this right down the middle of our hoop house, and then you turn it on, and as it sprinkles, as the water pressure shoots out and it does its sprinkling action, it'll also self-wind itself, and it will follow the hose in whatever pattern that you laid out the hose. If you laid out a hose in an S pattern, it'll come back in an S pattern. If you lay out the hose straight, it'll come back straight. Super interesting stuff, and they come in a variety of designs. Super neat thing to have, and it saves a human having to hold the hose there, which is one of my biggest pet peeves on a farm, is to pay a human to hold a hose. And there's so many things out there that you can do. And much like greenhouse, spacer blocks are also applicable. Heat sinks are also applicable to hoop houses, and shade cloth is also applicable to houses. That all help with your temperature control. Here's something else that's super cool. Has anybody used a vacuum seeder out there? Super worth Googling. Here is a YouTube video link there that we're not going to watch at the moment. But basically, you're looking at sprinkling a whole bunch of seeds onto your seed tray, hooking it up to your shop vac. That's what this here hose is for. It goes down to your shop vac. You turn on your shop vac, and then it sucks a seed into each one of these little holes here in the tray. And ideally, your seed tray matches your greenhouse tray. And so you turn that on, it sucks in all of the seeds, one seed per hole. All of your other seeds drop to down here because they have no suction and they all drop to the bottom. And then you put them into a little cup, say, over here. And then you position this over top of your greenhouse tray. And then you turn off your vacuum suction and you end up with one seed per cell exactly where you want it to go. And right now we are seeding those 128 trays is what we often use. And you're sitting there putting literally 2 seeds per cell for 128, and it takes you forever to do such a small little tray. With a vacuum seeder, you're just sprinkling out the seeds, turning it on, flipping it upside down, letting go of the vacuums, your tray is done. Amazing. Yeah, super interesting. Another option is a vacuum wand seeder, and the same thing, you can set up these little needles, they have suction power, and you can set up these little needles to match any kind of tray that you have. You have a reservoir of seeds, you turn on your little vacuum seeder, you dip it into your reservoir, you bring it over to your tray, you let it go, and you can see the whole row at a time. Neat little time-saving devices. Germination chamber is also perhaps pretty neat. You're looking at a place that has the optimal humidity and temperature to germinate whatever seeds you happen to have. On every single individual seed package, it'll have your optimal temperatures for germination and for optimal temperature and humidities for germination. And you get to set your germination chamber to match that, and you have fantastic germination. Now this is going to very high end, but you can also have what's called the iGrow greenhouse controller. This is the super high end Cadillac version here. And you can have greenhouses where you have multiple areas of the greenhouse set to different humidities, and different temperatures, and different carbon dioxide levels, and you can control it all from one spot in your greenhouse. That is like really super high end greenhouse kind of stuff. That is a picture of that rebar that we were talking about. And here I just wanted to stop and mention about anchoring greenhouses. Every time I anchor a greenhouse, I usually try to overdo it. The Hayes Farm hoop house is all built onto these 4x4 cedar blocks, much like you see in this here picture. And we have footings, so all of the greenhouse hoops sit onto those footings. And so by itself, sitting on these cedar blocks, the greenhouse would kind of be floating. And if a big wind came along, the greenhouse could get flipped over, no problem. So what we did is these cedar blocks, the 96-foot long cedar posts that we have all the footings attached to, we have those sunk with rebar. Using the 10-foot rebar lengths, we have one 10-foot rebar length sunk into each corner on an angle. There's maybe about two feet that stick up, and you can see those 2 foot worth of rebar in every corner of our hoop house. We have them covered with rags so that there's no rubbing against the plastic. So in each corner of our hoop house, there is a 10-foot long section of rebar that is sunk 8 feet deep. Then every hoop, you can see in our hoop house, we have 2 more shorter pieces of rebar. I think they're either 4 or 5 foot lengths, and we got those put in on an angle to each other. So we got like one there and the other one going down on a crisscross. And that's probably an overkill, but man, I would much rather overdo the anchoring of a greenhouse than underdo the anchoring of a greenhouse. If and when a greenhouse flips and goes blowing away across your farm, A, you've lost your structure, B, you've lost all the crops that were in there. It's a nightmare of a situation. Don't want it to happen. I have heard old-timey farmers say that one of the best tools that you can have in a greenhouse is a knife on a stick. Because if you're ever in a situation where your greenhouse is about to give away, you pick up that knife on a stick and you slash that plastic, because that plastic is worth far less than your greenhouse and the crops combined inside of your greenhouse, and you're just going to give up that plastic for the day, and then hopefully get more and replastic it as soon as you can, as soon as you can re-anchor it. Mind you, I don't have a knife on a stick in our greenhouse because I'm so confident of our anchoring situation. Cold frames. Let's talk about cold frames. Basically, same design as a hoop house. structurally wise, but can be made in a variety of shapes and out of a variety of materials. There isn't much manipulation on a cold frame other than having it closed or open or partially closed or partially opened. Hoop houses can be nice and rectangular in design, or can be small little hoop houses, or can be fancier, a little bit more higher end. These are all good examples of cold frames. Hotbeds is you're basically often looking at a cold frame design or built inside of a hoop house or greenhouse. You're looking at excavating a whole lot of the earth, refilling, well, this is the old school technique, refilling with fresh manure, backfilling then with enough soil that your plants are not going to go down to the fresh manure because that is too hot, as they say, and they'll actually burn the roots of your plants. So you want a good layer of soil, anywhere from like say 8 to 12 inches, and then a cover on it. And then this here will be a nice heated area to grow plants in. Here is a side example of exactly the same design. And then you can build the same thing inside of a hoop house or a greenhouse. As opposed to using manure too, we also talked that you could use heating cables or some of those, the piping kind of situation with either hot water or geothermal air kind of forced through there. And that's how you get a hotbed. Oh, and yeah, here's another example here using cables or hot water pipes. I had Amish friends that used to do this with the black kind of PVC piping that you see around here on the farm for the irrigation system. They would have one pipe that would extend about waist high up here, and they would boil water on their wood stove, pour the boiling water into that pipe and run it through the system. And then on the far end, there was a drain, so when that water cooled, that they can take it out. And then they would just repeat that system, and that's how they made their hotbed work. And then there's also heating mats too, which is a very small scale of a hotbed. I use heating mats to start plants at my house like way back in like March, April. And this is exactly the type of heating mat I use. They're relatively inexpensive. I wish I could give you a price on them right now, but I can't. They just plug in, and they just provide just a small amount of heat just to get your germination up.
For the manure one,
Yeah.
would you have to like refresh that like every now and again, or is that like?
Absolutely. After you're done growing in there, after you're like the season is done or whatever, after that growing period is done, you're looking at taking that manure out and then using that manure basically as composted manure wherever you want it to be used, and then putting fresh manure back in for the following crop.
Okay.
It certainly wouldn't just continually give off heat, that's for sure. Okay, so low tunnels, also known as mini tunnels. We are talking about the need for perforated plastic. As you can see, this here is different perforations than this. Relatively cheap stuff, unfortunately. I don't love using plastic. I've used my fair share of plastic with different operations over the years, and that's something I am purposely trying to get away from. I used to use more low tunnels to create more microclimates on the farm, but instead I'm now of the mindset that I would rather choose crops that don't need such specific microclimates. That being said, I sure did make decent profit using this here cheap plastic growing things under microclimates. And that's the rub of it, right? And that's what I keep kind of coming back to about how our economic system doesn't really match our agricultural system. Our economic system wants agriculturalists to use this kind of stuff so that you are the first to market, so you are commanding that price at market. And I was successful doing that, but I also used a hell of a lot of plastic, and I don't love it. I would rather choose to grow crops that don't need those microclimates. But then as a grower, that might mean I'm going to be a little bit less profitable. And that's the toss-up. That's always the rub in agriculture, it seems. Depends on what you want to grow for. Spring steel is what keeps up those low tunnels. That's what gives it the hoopy shape. Spring steel come in bundles of 100, sold for about $30, and they are indefinitely reusable. And they're great material to use. You can certainly improvise with different material. I've heard about people using the bendable rebar and PVC and conduit and this and that, but for the price that they're at, it's really not that expensive, and they're infinitely reusable. I highly recommend purchasing the wire hoops. So here we have a list of different pros and cons dealing with greenhouse management. I'm not going to get into a whole lot of time with that. We'll flip through those. 3 most important greenhouse management variables that we keep coming back to: temperature control, light control, and airflow control. And while we're here, we should talk about greenhouse timing, because you can't do it all in one greenhouse is my takeaway here. So the Hayes Farm hoop house, as you see, is used for starting our plants to make sure that we have enough seedlings so to be transplanted out when we want them transplanted out according to our crop plan. And that is the focus of that hoop house. That's the reason we have that hoop house. But we only need to start those plants for several months out of the early part of the year. And then for the other part of the year, the question is, okay, now we have this greenhouse space, what are we going to do with it? So then we choose to grow heat-loving crops in there, which are most often your tomatoes, peppers, eggplants, and cucumbers. And those are exactly the kind of crops that we will be growing in our hoop house. But you could manage it in a completely other manner if you wanted to. There is a farm in Peterborough, Ontario called Chickabiddy Acres, and they have 4 greenhouses that they manage exclusively for late and off-season crops. So they're growing greens and selling them in the dead of winter. And this is a technique that Elliot Coleman uses in Maine, and this is where they got a lot of their ideas from. These are passive greenhouses. They're not putting in any heat. And they're growing these greens. Well, they seed their greens. This is in Ontario, that is. They aim to have all of their greens seeded by the Labor Day weekend in September. Which means that if you are choosing to grow tomatoes, peppers, cucumbers, or eggplant, you're often harvesting peak harvest into September in a hoop house. And you'd be very reluctant to rip those out of there to plant your cold hardy crops. This is what I mean that you can't do it all in one greenhouse. You got to choose. And so at Chickabiddy Acres, they've chosen 4 of their greenhouses to grow cold hardy greens. They're seeding their greens in and around Labor Day weekend. They're growing their greens to full maturity in the hoop house for, say, mid-November-ish. And then again, no heat in these greenhouses. And then they choose to hold these greens in their greenhouse at a mature level. Because by the time you're in mid-November, your days are getting short, your temperatures are low, and the greens aren't growing very much, but they're there. They're there, they're almost mature, and they're just holding. And they will continue to hold like that all throughout the winter. Peterborough, Ontario, I think gets even a little bit colder than what we get here, what I've seen in Nova Scotia. I'm sorry, New Brunswick. There's consistent negative 40 days in the nights there at winter. And so what they do there is they put another layer of either plastic or row cover inside of their hoop house, and sometimes both. Sometimes they'll have a hoop house and then another layer of plastic, maybe about 6 feet tall in their hoop house, and then row cover over top of that, over top of their greens. And all of their greens are just holding. And then they get in there in the middle of winter, and whether it's January or February, and then that's when they start cutting their greens, and then they sell them through a CSA and a farmer's market, and they're able to command a premium price for having these greens in the middle of winter, and they do quite well with it. But as a result, their hoop houses sit fallow from like after they're done harvesting their greens, say like they'll come back in April. So their hoop houses will sit unused like during the months of May, June, July, August, and then be replanted in September. And a lot of hoop houses in Ontario during that time are bumping with crops, but they've chosen that's their fallow time in their hoop house because they're doing it opposite. So you can do lots of things with hoop houses. It's very cool, but you can't do everything with one hoop house. So you often got to decide what your focus is going to be. Here's a little chart, pros and cons kind of chart about temperature control versus light control versus airflow for different styles of greenhouses. And one final word about greenhouses is rodent control. You always have to worry about rodent control on the greenhouses. Rodents love a greenhouse. According to certified organic standards, which of these can you use in your greenhouse?
Sorry, is that black thing a George Foreman grill?
Black thing is a rat trap.
Okay, it looked like a George Foreman.
This is where you would put your poisons in your bait stations, and the rodents go in and eat your poisons.
Or you could just eat the rodents.
Or you can eat the rodents. That's what this cat's working on.
Is
So
poison used?
what was that?
Is poison like actually used?
Heck yeah.
What about the cascading effects of using poison?
Fantastic question, Matthew. Thank you so much for that one. Fill us in. What are you talking about there?
What am I talking about? Like, I guess if a rat consumes some poison, it doesn't die there. It's going to return somewhere. Maybe it dies. Maybe it hasn't died yet. An owl picks it up, consumes that, and dies as a result of consuming poison.
Exactly, and that is the reason that is not allowed in certified organic agriculture. In certified organic agriculture, they want you to use cats. They want you to use kill traps. They do not want you to use poison. This picture here is a little misleading because you have both a kill trap and what looks to be a little bit of rodenticides and poisons here. So you got a little bit of both happening.
And so the cats are an option?
Cats are an option for a greenhouse in organic ag. Now, I knew somebody, Maryland Organics, they operated a certified organic flour mill. And the certified organic people didn't want him to use poison, they wanted him to use cats and kill traps. And then the health inspectors would come by and they say, oh, we don't want you to use cats, we want you to use the poison. And so he was always in a position where when the health inspectors came by, he put out the poison traps. When the certified people came by, he took away the poison traps. And he was always in this weird position because he didn't know what he should do. So, but he tried to opt more towards cats. Why are you surprised about cats?
Sorry, it makes me think of, because cats should, I don't know, I'm of the opinion that cats should be indoors. They're an invasive species in the wild. They kill lots and lots of birds.
Yep, you're absolutely right.
That's interesting. That's weird stuff.
Yeah, it is. It's weird stuff. I completely agree. And what we are trying to do, though, at Hayes Farm is we're trying to go with that mint option. And what I read is if you have a nice bed of mint, rodents don't like to travel through mint, and that's what we're going to try to do. We're going to try to put a nice bed of mint around the hoop house. We're going to see how that one goes. But nonetheless, you should have a plan in place for rodents. You don't want to have a whole bunch of rodents in your hoop house. That's always a bad idea. Okay, so there is a quiz, but I don't think I want to do the quiz because I still have some practical skills thing I wanted to talk about, and I don't want to hold you guys online forever today. Okay, so what I do want to talk about though is I'm hoping everybody has some takeaways of those 3 major greenhouse variables to manage. You want to shout those out?
Temperature, airflow, and light control.
Right, so keep those in mind every time you check in on the hoop house, whether you're there doing your check-in by yourself in the morning or the evening or the weekend, or whether you're there in the middle of the afternoon with everybody on farm. Every time you enter the hoop house, ask yourself, how is the light situation in here? How is the airflow in here? How is the temperature control in here? Those are all things you want to ask yourself every time you step into the hoop house. Then beyond that, as I was saying, those are the kind of like the macro variables, and then you also have the micro variables, which are your individual plant needs, your water for your individual plants, your fertility for your individual plants, and the soil for individual plants. Now, soil is often where I would now pause things and we would go over to the Hayes Farm hoop house and we'd start talking about soil and potting soil and soil types and soil structure in the hoop house. For you guys that are starting your own seeds and this and that, how do you select what potting soil that you're going to use to start it? Because it's confusing. The potting soil world is damn confusing, and I think it's almost on purpose. When you walk into a store and you look at all the different choices available to you, how do you choose?
Usually on the like seed packets, it'll tell you which potting soils to use sometimes. Like I know we got watermelon seeds and it told us to use like cactus soil.
Super interesting. Why do you suppose it would tell you to use cactus soil?
I suppose, I'm not too sure. I know it's like some sand and some like soil, I guess because it's for like hotter areas, maybe? I don't know, like, I'm not sure.
Anybody else? Advantages of cactus soil?
Because drainage.
Drainage,
And
all about the
over.
drainage. When you put water to cactus soil, or what's sold as a cactus soil, it practically runs right through it. It's almost like a sieve, and that's what watermelon's like. Rosemary likes that as well. Not every plant likes that though. Some plants like wetter kind of mediums. In general, in a hoop house, if you're growing a variety of crops and you're looking for a potting soil, you're going to try to find a potting soil that's going to be good for everything, unless you are a very specific grower and you're just growing melons, and in that case you might want one of those super drainage kind of potting soils. People out there that have started plants already, what are you using for potting soil? What have you chosen to use?
We buy this, I know it's like Humboldt soil.
Okay.
It's from Humboldt, wherever, I forget where that is. It's in the States somewhere. Is it California? My husband picks it up because he believes it's a better soil. We tried like the all-purpose one from like Walmart, and we're not very successful with it. I don't know if it's the soil or if it's us, but we switched it, and yeah.
There's all sorts of different qualities out there, and it's kind of like buying dog food, eh? In the end, you're feeding it to your dog, but they're selling it to the human, you know? And like the potting soil mixes will put anything on a bag to sell it to you, but it's up to you to kind of decide what's good or whatnot. And if you can find something you like, by all means, stick with it. If you were going to go out and buy potting soil, who would be inclined to buy organic potting soil versus conventional? Organic, would anybody be inclined to pay the extra dollars to buy the organic soil? Anybody okay with just the conventional? And it's okay to be honest. It's okay to buy conventional soil. According to some of the fellas that I've talked to, so much of the potting soil that's out there, first of all, is soil-less. There is no soil in potting soil. The main material is often sphagnum peat moss. And I've talked to some people in stores and this and that, especially over at the co-op. The co-op often orders in soil from a company. It's a German-based company. They call themselves ABS, but they have some plants in Nova Scotia and in New Brunswick where they make this soil. And that's when you buy the soil at co-op, that's where it's coming from. It's not coming from Germany, it's coming from here, local. They tell me that their certified organic mix and their non-certified organic mix is the exact same thing. Because the sphagnum peat moss is all coming from wild sources, it's easy to get it certified. And they choose to sell some as conventional and choose to sell some as certified in order to hit both of those kind of crowds. Now, I'm not saying that every conventional bag can be organic, but just in this case, in that example, that is. And it's a bit of a money grab. You could be buying just like regular soil, conventional soil, that is the exact same thing as the organic, and you're just paying more for the organic. The potting soil world, I think, is deliberately confusing. Who's heard of soil mycorrhizae, and would you be inclined to buy potting soil with mycorrhizae inoculate? You want to talk about that there, Matthew?
I don't know like a whole lot more. Like I know, a little bit about mycorrhizae. They will attach to the roots of a plant, and they'll form little nodes, and it's like a beneficial kind of relationship that'll help the plant take up nutrients more easily while the fungus kind of borrows some of that nutrients at the same time for itself.
Super great. How many average home yard kind of growers do you think knows that though? And you know what I mean? And so you're in this potting soil aisle and you got one that says, oh, mycorrhizae, that sounds fancy. And basically that's the reason people are buying it, is it sounds like it's sciencey. But if you bought regular potting soil and then went out and purchased mycorrhizae inoculant, you can probably inoculate your own soil for much cheaper than what the price of the potting soil is. You know what I mean? And these are all just different things that are in the potting soil aisle just to deliberately confuse you, just to deliberately get your money. My point is though, if you find something that you like, for whatever reasons, maybe it's local, maybe it's organic, maybe it's this, maybe it's that, If you find something you like and it works well, stick with it. It's great. Right now, I've been using an organic soil, potting soil that I've been purchasing over at the co-op. It's called Moisture Lock, and it has more elements in it that hold water. And I find that is great when I am starting plants in my house with my wood stove. That's often where I start them, is next to the wood stove, because that's my warmest room in the house, and it dries out quick in there. So I often buy that Moisture Lock kind of stuff. And I'll only buy that at the beginning part of the season when I'm starting plants at home myself. And you'll see a couple of those bags around. They're available in the hoop house. There's one in the back of my truck right now. But then once I start starting plants directly in the hoop house, I don't need that Moisture Lock anymore, because as you can see, the hoop house holds its moisture extremely well. So it's a very wet, humid environment. So I want kind of the opposite effect. I want more drainage, and I want more of that kind of more cactusy kind of soil. Who knows about vermiculite and perlite? Anybody want to jump in there?
Vermiculite is, I believe it comes from like lava rocks, and it also like holds moisture.
And perlite?
Is it pretty much the same thing, or?
Your start is right. It also comes from rock, but it does the opposite. It
Okay.
helps it drain. I was mentioning about that damp off disease. When I'm starting plants, I will often use perlite on top of the soil of plants, and I've recommended this a couple of times for inside our hoop house too, for a little bit of perlite sprinkled over top, and that dries out the surface a little bit. Just underneath there will be nice and moist, but that very top surface will be a little bit more dried out and will help you against that damp off, which is often caused by too much wetness. So vermiculite is nice. It soaks up water and releases it slowly. Perlite allows it to drain through. Both are rocks that are usually byproducts of other mined materials. I don't know of anybody specifically mining perlite or vermiculite. It's usually you have, I don't know, whatever, an ore mine, and then you also come across a vermiculite or perlite, and then it gets processed for that. Coconut coir. Does anybody know about coconut coir? That is often a mix, something that you'll find in potting soil as well, and it's just the husk of coconut. And it's used because it's, again, a soilless material. It allows perfect drainage. It really doesn't hold any water. It's just a kind of a medium that allows plants to grow inside of it. Doesn't provide any nutrients either. It's kind of bulk, and just allows water to go through. We mentioned sphagnum peat moss. Sphagnum peat moss is another ingredient that's often in potting soil, and it is a bit contentious. Anybody know why?
It's a limited resource. It takes many hundreds of years to build a peat bog.
Yeah. And I know some certified organic growers that don't like to use it, that go out of their way to avoid using sphagnum peat moss. By creating our planters that are filled with topsoil and compost, we are getting further away from using potting soil in general, and especially the sphagnum peat moss and plastics too. So the planters went a long way to solving a lot of these little issues for us. I don't love buying in sphagnum peat moss myself. Yeah, it does great destruction. It's worth taking a look at, whether it's in person or by Google, what happens when sphagnum peat moss gets mined out of the environment. It's just devastation. So what can you use instead of sphagnum peat moss? Coconut coir was mentioned, except coconut coir comes from far away.
Wood chips.
Wood chips. Wood chips aren't great to use for growing plants because they absorb nitrogen. They'll lock up a lot of nitrogen while they break down, starving your plants of the nitrogen.
Would hay or straw?
Hay and straw is interesting. However, I would take it one step further. I can never see plants like seeds being planted on hay or straw. However, hay or straw compost is where it's at. And so compost is the answer here. If you're trying to get away from using sphagnum moss-based potting soils, compost-based potting soils are usually your alternative. They are very hard to buy though. In the potting world soil, everything is all peat moss or coconut coir based. Very rarely will you see a compost. I've never seen one available except like to purchase specially online, that kind of stuff. So if you're looking to make a potting soil out of compost, often you're looking at having to make that yourself. And there are recipes available. And you don't necessarily need to make the compost yourself either. You can buy in finished compost and then mix it with your vermiculite and perlite. Perhaps throw in a handful of coconut coir. Perhaps throw in some vermicompost in there as well. There are mixes online that you can go and research in and make your own compost-based potting soil. I also mentioned vermicompost in there. Anybody have any experience with vermicompost? Do you want to fill us in?
Compost produced by worms, so it's what worms have eaten.
Yes, exactly. What passes through the worms, and you end up with the worm castings, which is a fancy word for worm poop, which is super fantastic stuff. And we'll talk more about that, dive into the vermicompost world during our composting lecture. That is something I have put plans forth to the Hayes Farm Steering Committee to help us manage our fertility management here on the farm. For the last couple of years, we've been buying in compost outside of the farm. I'd like to produce a whole lot more on farm, and I think vermicompost is the answer. And we'll explore that a bit more during our composting lecture. Who has worms at home?
I don't have them at home, but I've raised them before.
I got a full worm bin at my homestead there that I'm looking to divide. I do this yearly at this time and then bring the half of my worms here to Hayes Farm, and then we look after them for the season. At the end of the season, because I don't want to bring worms back home, you guys are available to take any worms if you guys want any. I'll give you worms, Matthew, no worries. And then I set them free into our planters at the end of the year, and I'm really hoping to establish a worm population out in our greenhouse planters. And as I dig around in our greenhouse planters, occasionally I do come across a red wiggler, and I get so happy.
This is an aside, but my favorite fact about worms is that they're non-native to North America and that they don't belong here.
And they're changing our ecosystem.
Absolutely. We have way more soil than we should, but hey, I guess that's good.
Yep. Little tractors. So we talked about organic versus, go ahead.
Sorry, worms aren't native?
No.
Fill them in, Matthew.
They're just like one of the most invasive things on the planet, and they came here probably on boots and ships, and now we have worms everywhere.
And when I say they're changing our ecosystem, the North American forests have seeds that are so fine that worms do eat them, the invasive worms do eat them. And as a result, it changes that seed. Sometimes it makes it sterile after passing through a worm. And the ecosystems in our forests weren't made with these worms around. So the worms that are introduced are literally changing our ecosystem here by changing the seeds of the plants.
There's two types that are native, right? Like night crawlers, and then I think there's the red one, the red wiggler is native. It's just like common earthworms that aren't.
It's the larger one that is not, the larger one that is capable of digesting those seeds that I was talking about. Okay, so we talked about organic versus conventional potting soils. We talked about inoculant and mycorrhizae. What about nutrients? So if you buy a potting soil, and it specifically does not say that it is fertilized, some potting soils will have some numbers. So, well, let's take a step back. So often with fertilizers, you'll see 3 numbers on a fertilizer bag. That's your NPK, right? Does this sound familiar? That's your nitrogen, phosphorus, and potassium. And you'll have 3 numbers in a row, and they could be like 2, 10, 10, and that means like small amounts of nitrogen, medium amounts of phosphorus and potassium. Or they could be 20-2, or all these different numbers, and that represents your NPK, nitrogen, potassium, phosphorus, and potassium. And those are your macronutrients. And in the conventional farming world, that's the ones they look at the most. In the organic farming world, we look at a whole range of macro and micronutrients. But when you're buying potting soil, sometimes you will see very light amounts of fertilizers in a potting soil. So if I see a potting soil and it has 555 on there for an all-purpose kind of fertilizer, first of all, I know it's a conventional fertilizer because hardly ever is organic fertilizers written as that. So that's a bag I will stay away from because I know there's conventional fertilizers in there, and conventional fertilizers will burn your earthworms, and earthworms are my friends. So I tend to stay away from that. But you can buy certified organic fertilizers with nutrients in them as well. And you can buy certified organic fertilizers without any nutrients in them. Advantages or disadvantages? Any thoughts out there? Silence. Often with potting soil, even if it is so first of all, your seeds, when you plant a seed has everything it needs to grow in that seed up to the point where it produces a true leaf. The first stage of a seed, when it germinates, it will produce its first set of leaves, cotyledons they're called, and they are not their true leaf. If you notice a plant, when it first germinates, the first set of leaves it throws out is false leaves, and the second set of leaves that come up from the center of that is its true leaf. When a seed is first germinating, it has all the nutrients it needs to reach that first leaf stage. After that first leaf stage is when you should consider putting some sort of nutrition to that plant. That nutrition can be delivered through the potting soil medium itself. They can be watered in at Scott's Nursery. Every time they water their plants, they're using fertilizer, chemical fertilizer at that too. And if you want plants grown at Scott's Nursery without chemical fertilizer, you have to clearly indicate that you just want plain water on your plants, and they will do it for you. I've had it done. So there are different ways to add nutrients to your plants. But why would you choose to buy a potting soil with fertilizer in it versus a potting soil without fertilizer in it? If you're germinating something for a long period of time, say if celery or parsley comes to mind, where it takes like 3 weeks to germinate, and you're using the potting soil that has quite a bit of nutrient in it, sometimes you can get algae growing on the top, or sometimes some mold or funguses will grow on the top from that extra nutrient. And that kind of takes away from your plants. It doesn't look so nice. And so a lot of people will go with potting soil without any nutrients because of that. However, if you're growing something that's really quick to germinate, sometimes it's really nice to have that nutrient in there, and that way you can put off potting up. You can grow them in that cell just for a little bit longer if there's a little bit of nutrient in there, whether it's in the potting soil or whether you're adding it. So to add nutrient or not to a potting soil depends on kind of what you're growing and what your plans are for it. If you want to leave it alone for a long time, just where it's at, maybe you want a bit of nutrient in there. If you're able to provide nutrient through water, through a compost tea maybe, or a vermicompost addition, then maybe you want a potting soil without any nutrient. Then we talked about additives. Okay, so one additive we did not mention is a wetting agent, and that is something you will see on an ingredient list inside of a bag of potting soil. You'll see something that'll literally say wetting agent. What does that mean? A wetting agent. Go ahead, Matthew.
Well, I'm not sure exactly what it is. I just know that in the past I had a patio and I tried to grow a container garden on it, and I had these like little jelly things appear in my soil, and that's what that would be. And I think it's something like you can do decorative things with like it's like fake, I don't know, like a water.
Wetting agents come in to different sizes and shapes and functions. Some are kind of straight up chemies, and some are just little gel kind of things, and they're just made to hold water for longer. Generally, wetting agents will indicate that it's a conventional soil mix, and sometimes wetting agents are a little chemi based and this and that. So if a bag of potting soil includes the word wetting mix, I tend to stay away from it. I would rather add vermiculite myself than whatever kind of wetting agent that they're unspecified put in there. And trust me, this is way funner to do in the greenhouse than just by over Zoom. But that wraps up our greenhouse lecture. Any questions about that? I would invite you guys to kind of anything that we talked about, just kind of keep your eyes open in the greenhouse for. I'm sure you'll see examples of everything that we talked about, from light control and air control and temperature control and potting soils and all this kind of stuff. It's all in action in the greenhouse right now. All right, if you guys are good there with greenhouse management, I'd like to finish up practical skills from the other day, and I really don't want to spend too much time. I don't want to keep you guys online here forever. So practical skills from the other day. Basically, the point of this here talk was just to kind of get you guys thinking about the bare minimums of categories that we need to kind of have under our belts in order to manage, in order to work on the farm here. One of the things we talked about the other day was the start of my list was the thinking and problem solving abilities. And I mean, that comes with experience. There's nothing much I can tell you about that at the moment. Besides that, what I mentioned before, that most of farming is all about problem solving. You're just kind of often doing the best with what you got, trying not to spend too much money on whatever problem that you have that comes up, and trying to come up with creative solutions. And you know, the only thing that can help you out in that is a bit of experience. Hopefully we'll teach you some skills there as far as that goes as the season progresses. Now, another thing here, and we mentioned it when we had a bit of a go around and talking about different skills, another thing here is water management. Oh, I just saw a note to self here. Before I talk about water management, let me take one step back here. The thing about growing skills is that on a practical level, I think that it is very fun and enjoyable and rewarding, and anybody out there can grow a tomato or a carrot or a cucumber. However, it becomes very difficult to make a living growing a tomato or a carrot or a cucumber. Growing these things, you can throw a lot of money onto things, and you can grow a very expensive tomato for yourself. But as long as you get that reward at the end that you're looking for, that money didn't matter along the way. However, when you're trying to make a living from gardening, it becomes much more hard work. You can't just spend like crazy to grow that tomato. You have to be practical about it. There's always more things to be done than time allows. As I mentioned before, you can't spend a whole day weeding one bed while the whole rest of the farm goes out of control. And there's always compromises to be made. And so one of those compromises, especially in the context of the problem solving, is anytime a problem comes up, yeah, it's easy to throw money at it and solve it that way. But if you're trying to make a living doing this, you got to be able to be creative. So that's all goes with problem solving. Next, I want to talk about water management. So our irrigation system at the farm, each of you guys are expected to be able to run that irrigation system. I just have it set up there on Friday, got it up and working, pressurized. There's a couple of folks around there that I was able to give a brief introduction to. However, as your greenhouse shifts come up and your weekend and evening shifts come up, how we are watering that hoop house now is just through the pressurized water system, through those irrigation tanks. So I want you guys to be able to know how to run that in case you are by yourself doing a hoop house check. Right now in the early days, we're trying to pair you up with a farm mentor, and all of our farm mentors know how to run the system, but it's going to be up to you to know how to run that system. So if you're on farm, say on a Wednesday, and you have a hoop house check that Wednesday night, take me aside, let me know, and let's make sure you know how to run that irrigation system. In years gone past, I brought everybody together and we only had to do it once. But COVID being COVID, I'm gonna have to kind of do individual tutorials, and that's gonna be just fine. We'll get through it. And I want everybody to be able to know how to run that irrigation system. So over the next day and a half or so, well, starting tomorrow afternoon and into Wednesday, I'd be don't be afraid to pull me aside and get a small tutorial about how to water the hoop house and how that irrigation system works. Right now, I'm going to go into some just broad strokes about what that irrigation system looks like. It all starts with those big irrigation tanks at the north end of the laneway. We have 6 tanks all hooked up to each other in tandem. The piping, the tanks go through a PVC pipe to our pump. That pump feeds a pressure tank, which gives us nice even pressure through the system. And then that pressure tank leads to a poly pipe, which is then separated by valves and T-splits and runs basically all over the farm. Every field block area has its own individual turn on, turn off valve that will eventually be hooked up to drip tape. And we'll get around to doing that as our gardens get populated and the weather gets drier. Right now, you just need to be able to run the irrigation system to water the hoop house. After we have the drip tape set up in each of your field blocks, which will happen over the next week or two, then you're going to have to be able to run the irrigation system with the intention of running the drip tape. But we'll get there. First thing we're going to figure out is how to water the hoop house. And as I was saying, I think that's going to be best accomplished by you guys taking me aside in groups of 1 or 2, and I'll show you how to operate the water system in order to water the hoop house for your chores. So sometime on Tuesday afternoon and anytime on Wednesday, I would love for you guys to each take some initiative, pull me aside, and I'll show you how to run that system. It should just, in theory, if it's set up well, which it is right now, it should just be as easy as plugging it in and then going over to the hoop house and running the hose. But I kind of want you to understand the nuts and bolts of it. Okay, so we talked about problem solving. We touched on water management. Another thing in the practical skills department is pest management. Now, when I talk about pest management, we're talking from everything from the 2-footed to the 4-footed to the 6-legged. On the very small scale of things, one thing that you will see us use a lot around here is the row cover. Does anybody have experience playing with row cover? Row cover is, I feel, is another product I feel a bit guilty about using. It is a plastic product. It is a spun plastic that we are using. It is intended to be disposable, meaning it's only supposed to be used for 1 season. But we reused the HE double hockey sticks out of our row cover, and I have pieces that have been with me for over 10 years. The red tuck tape really works well to hold it together. It does a great job. Row cover is great because it excludes insects. When you're using row cover, it can be a bit of a pain in the bum because you have to bury in all of your edges all around the entire bed. And if you want to check on your crop for harvesting, for weeding, for monitoring of any sorts, you have to unbury one side, flip open the row cover, do your work, rebury or re-row cover it, and rebury your row cover. Big pain in the bum, but it can provide near perfect protection from insects. And this week in particular, I'm hoping to row cover all of our 4 garlic beds. And that means we have to go out there with hose, create a trench around the garlic bed itself, put the row cover on, and then bury the very edges of the row cover so it's nice and billowy in the center so the garlic has lots of room to grow. And that is one thing that we use for pest management that we will use quite a bit for pest management. Another thing we will use for pest management on the farm is diatomaceous earth. We talked about that one already. That's that very fine white powder. It is excellent for slug control, and in a heavy mulch system such as we have, we do attract slugs. I've been thinking about setting up some slug traps this year. Does anybody have any experience dealing with slug traps? What did you use, Matthew?
Beer.
Yeah. Yeah, in little cups, and they drown.
Yep, it's kind of sad, but
It is kind of sad. Shireen has also mentioned soaking rags in beer. And then I'll have to ask him more about this. And then in the morning, you go around and just collect the rags, and apparently they're just full of slugs.
oh, that's beamer me.
But I think they still get killed at the end, I'll be honest. Bran is another one I've heard used with slugs, and they'll eat the bran and then they're not able to digest it, and then they blow up. But I would like to play around a little bit with slug traps this year. This is something I've thought about. I've got a couple of ideas up my sleeve. If you guys want to research any, I'm totally down with it. You will most likely run into some slug problems sooner or later in each of your field blocks. Live animal traps that you see around here is something else we use for pest management. The live animal traps, yeah, they are what they are. I don't got much more to say about that. There's a certain skill to setting them or whatnot. I've already caught 2 animals there this season. I'm sure something else will come along and there'll be more opportunity to set traps. I won't get into too much more detail than that at the moment. And I should mention, we specifically have a class on integrated pest management, and that's when we will go a little bit further down the pest management rabbit hole here. But my last thing here I wanted to mention in the pest management, and perhaps the most important one here, is the electric fence for the biggest pest of all, and that's our deer friends. I quickly wanted to go over the different electric fence components. Much like the irrigation system, each and every one of you is required to be able to operate our electric fence system. There's not much involved with operating. It's mostly just monitoring, but you should know how it's set up in order to know how to troubleshoot in case a problem comes up. Now, I have something here I wanted to share. Here is your typical electric fence system. I like this one because it has a human in it. Most pictures have animals getting shocked, and I like the human getting shocked better. So your electric fence system all starts with your energizer. And that's a box that currently sits in the garage on the back wall behind the walk-in cooler. From the energizer box, there are 2 knobs on it. Well, there's 2 knobs and a cord. The cord is just as simple as plugging in and it's on. Then there's 2 knobs. You have your hot knob, which is your fence line, and you have your ground knob, which is your terminal, your earth terminal is what it's called in this picture. If your electric fencer is not delivering the charge that it's supposed to deliver, and there are no obstructions on the electric fence line, like 99 times out of 100, it's because of a poor ground rod. Your ground rods here are the most neglected part of your electric fence system. I like the fact that there are 3 of them set up in tandem in this picture, because that is what you should do. At Hayes Farm, we have 2 ground rods set up. The more dry or cold or arid of an environment that you live in, the more ground rods you need. We tend to be rather wet and clay-like here at the Hayes Farm, so we get away just fine with 2 ground rods. Your ground rods should be 6 feet away from each other at a minimum, such as ours are at the Hayes Farm. And everything comes, if you don't have your ground rods properly set up, you would never get a charge of the electric fence. In order to get a charge of the electric fence, you need to create a loop. Here you have a loop of hot electricity coming through the wire, touching the human through the ground to these ground rods creates that loop, and that's how you get your charge. It's all about those ground rods. Fortunately, at the farm, these ground rods are already well set up. You guys will have nothing to, don't have to, I'll point them out, and I'll let you know where they're at, but you shouldn't have to tweak these at all. So from the electric fence, what I like to set up is a double insulated line that runs out of the electric fence box. That means that your hot wire is in between 2 insulated layers of perhaps plastic, I'm not quite sure. But if you touch the double insulated line, you will never get a shock. The double insulated line simply leads from the box to your wire. And then as soon as it touches that wire is where you hook your double insulated line up to that wire, and then the whole thing becomes charged. You don't want to have any shorts in your electric fence. Shorts will come from, say, a tree branch touching the wire, and that will draw out some of the electricity. You don't want to have too much grass and weeds growing up to that bottom line, because that will create a short and weaken your electric fence line. Here in this picture, I like that they included these birdies. Birds can land on them no problem. If you're able to hover and touch the electric fence, you will never get a shock, because you need that closed loop system. So birds will never get a shock unless they're also touching the ground at the same time. That's basically your electric fence diagram here. You can also get something in there that's called a lightning diverter. And if a lightning strike ever hits the electric fence anytime along the electric fence, that lightning will travel all the way back to your fence box and fry it. I've had that happen to me once in Ontario, and it sucks. And you have to go back out and buy a whole new $300 fencer, when you could have bought a $20 lightning diverter that just dumped that charge into the ground and would have saved you a whole lot of money. Now the funny thing is, I went to go buy a lightning diverter here in New Brunswick, and they don't sell them. That's not a thing. I'd have to order it in online, they said. So that tells me that it's not a problem in this area. So I've never set up a lightning diverter on our electric fence here, and I've never had a problem. But in Ontario, it's a very real thing, and almost every electric fence that I see operated has a lightning diverter on it. Another good element of electric fence is your fence tester. A fence tester, let me see if I can find a picture of a fence tester, is a very simple device that allows you to test the fence without getting shocked. Isn't that nice? Without an electric fence tester, you're looking to have to manually test the fence. And I can show you a technique on how that's done. This is ours. This is what ours looks like. Very cheap versions, I think, is purchased. There you go, for what I was going to say, under $20. This one here is listed for 14 or 15 bucks. This hook at this end is what goes on to the electric fence wire. This here gets stabbed into the ground to create that loop. And how much power is running through your fence will be indicated by how many lights flash. How an electric fence works is that it sends out a pulse of electricity, like once a second. And in between those seconds, there is no electricity running, but it'll just send out one pulse every second. And so when you're testing this, it'll light up and then go back down, light up and go back down, light up and go back down. And so whatever the maximum light is where your electrical charge is for the fence. I try to aim to have something up along these lines. As long as these two are lighting up near the top, even if the second one here is lighting up near the top, no problem. Even if you just get 3 lights to the middle, that's still well enough to keep any animals away. Animals really don't like electricity. When it gets down to just 1 or 2, that's when I start to get a little nervous, and that there's probably something shorting out the line, whether it's too much weeds, a tree branch touching it, something. Then you have to start walking the electric fence line to find out what the problem is. The old farmer's technique, if you don't have the electric fence tester, is to simply grab a blade of grass, and then you touch the blade of grass to that electric fence, and you'll feel a very light charge come through it, and that saves you from having to get a very big charge, because electricity is not fun. So that was, we were talking a bit about pest management and specifically the electric fence system. I could go on a bit more of electric fences. I like setting up electric fences. I find them a lot of fun, but I find it more practical to kind of show you these guys, these things on farm. And much like the water system, as soon as the electric fence is set up, I'd like each of you to kind of pull me aside in groups of either 1 or 2, and I'll introduce you to the electric fence system as soon as that gets set up, which I'm hoping is by the end of this week. Okay, so next in the practical skills department, and I am trying to wrap up here, is fertility management. My message here in the fertility management department is, especially on a regenerative farm, fertility management is a long-term approach. There is no kind of quick little boosts, quick little fixes. We can do a couple of quick little boosts and quick little fixes, and in the past we ordered in fish emulsion to spray with a backpack sprayer to boost plants. I did that in year 1 because I didn't really know what I was dealing with here on the farm, so we did that as a boost in year 1. But as we go on and we do our proper crop rotation and we do our proper cover cropping and we do proper composting techniques, we do proper mulching and all these kind of stuff, and we're managing good mycorrhizal fungi activity in the earth, I find that there is less of a need for those individual boosts. And as a matter of fact, the regenerative farming approach tells you that there is almost always, unless you have a very weird kind of soil that has been abused over the years, whether it's from decades of conventional farming or whether it's some contaminant dumping that has taken place. If you have just a regular sod soil, backyard, something that's just been left like Hayes Farm for a number of years and you're trying to reclaim, most often the regenerative farming approach will tell you that there is enough nutrients in your soil. That what you need to do is to activate or stimulate the natural bacteria, the natural fungi, the natural microbes in your soil in order to make those nutrients available to your plants. If you were to go get a soil test done, a soil test will tell you what nutrients are available in your soil. And a good soil test will tell you how much nutrients are available to your plants in the soil. Just because you have calcium in your soil doesn't mean that calcium is available to your plants. You need that soil life in there in order to be that middleman to deliver that calcium, say, to your plants. Does that make sense? So that is a very regenerative farming approach to fertility, and we'll have a whole talk about that, a whole separate section lesson to talk about that. Yeah, so let's park that fertility management. Another one here in the practical skills department is seedling management. And that's just starting your little seedlings off in a hoop house. And we're kind of talking a little bit about that with our greenhouse management and how to start seedlings in the potting soil mix and watching it for damp off and that kind of stuff. And the best thing I can say for you in the seedling management department is kind of jump in and pay attention in the hoop house. Spend some time in there, do some seeding, do some transplanting. Aldea did a great job last week. I'd like to see somebody else in there this week spend some time doing some seeding and transplanting on like Tuesday, Wednesday, Thursday would be great. And then the final thing I wanted to mention here in the practical skills department is the harvesting and post-harvest handling skills. I have seen too many inexperienced growers grow beautiful crops of you name it, and then kill it, just kill that crop, vegetable murder with their harvesting and post-harvest handling skills. You could take a absolutely gorgeous head of lettuce, and by the end of the day, that head of lettuce is just wilty and looks like hell. Or you can take a gorgeous head of lettuce, treat it well, and then in 2 weeks' time in your fridge, it's still looking fresh and vibrant and ready to go. Those are your post-harvest handling skills. And I am really good at post-harvest handling. I've done lots of different experimenting over the years, and we have a specific class on post-harvest handling, and we'll specifically be doing post-harvest handling ourselves when our harvests come in and this and that. And that comes down to harvesting at the right time of the day. You don't want your plants to be too hot when they're harvested, treating them well after they've been harvested. There's a lot of little tricks in there for the post-harvesting and post-harvest handling. Okay, so just to quickly recap the practical growing skills here that we stretched out over 2 days. I was mentioning thinking and problem solving abilities as a particular great practical growing skill to have. Water management was mentioned as another growing skill. Pest management was mentioned. Fertility management, seedling management, and then harvesting and post-harvest handling. So those were 6 things that we just talked about there, just to wrap up our practical skills lecture. And